Now that you've completed the density of Penny's lab, we're going to look at how to complete a lab report. So after you do a lab report, you will be given a template to write the lab report in. You will be given a cheat sheet to help guide what you write, and you will have a rubric for grading of that lab report. So this is what the template looks like. It's not. So when you get it, you'll have name 1 and name 2. This is only for if you are submitting a lab report and sharing the grade with your lab partner. So if you're submitting it individually for different grades because you've done different things, you've written your different lab reports, then you do not put anybody's name here. If you're submitting it with your lab partner because you either are taking turns or collaborating, then you put just the person who is not submitting its name. Now, the reason that there's two names, name 1 and name 2, is if it's a group of 3. So if it's a group of 2, you would just put your lab partner's name. You can delete name 2. Okay. Don't forget you'll lose credit if you submit 2 of the same lab reports. So make sure that if you're sharing a lab report for the grade, only one of you submits it. All right, so there'll be a title, a purpose, background, data, a conclusion, summary, and questions. Now, just to kind of give you an idea of moving forward what these categories are, title should just include the title of the lab. You can steal that right from the procedures. The purpose, you're going to say why we did this lab, what the purpose of the lab is. I'll get into specifics when we talk about the density of the Penny lab. The background is going to list any relevant information. Basically, this section is so that if someone, a 6th grader, were to read this lab, they'd have enough background knowledge to understand what the results meant. Right? It's going to be about a paragraph. If there's a cheat sheet, there almost always is. Make sure to include all the topics indicated. Okay, and it's going to be again in a paragraph form, not in bullets. Data is where any tables, graphs, drawings, photos, anything that you got from the lab, it goes in the data section. Everything there has to be labeled and titled. You also have, if it's a microscope drawing or picture, it has to have the magnification as well as what object it is. All tables have to have a title, and you have to have a key, and the axes have to be labeled properly. Otherwise, you don't even know what the graph actually is. I do, but someone that was reading it would not. You'll get a 0 for the graph if it's not labeled or the axes aren't labeled, if it's not titled or if it's not labeled. Otherwise, no one knows what that information is. All right, so I'll go back to this, but I just want to tell you what's in every single lab report. The conclusion, you need to restate your data. So you might have pictures, you might have numbers. You have to restate it in a sentence form so that someone doesn't have to look at a chart. So you'll write a sentence and include all the data that's important for this lab. And you're also going to talk about how does this tie into what we're learning in class. So you're going to explain kind of how the data fits into what we already know or what we're learning. And it should be about a paragraph. And then the questions, you'll get lab-specific questions, and then you answer them in sentence form. Not as an answer to the question. So you rephrase the question in the sentence slash answer. Okay. So let me just pop over to the rubric so you know where the grade is coming from. Title and purpose must describe the lab. This is what we just talked about. So 5 points if it's well composed and accurate, or 1 if you put the wrong title or a purpose that doesn't even fit the lab. Background, you have to include all the information that's relevant to the topic that's in the cheat sheet. and they have to be in sentences. So you can look through this. If you show that you understand it and you're writing this information in the proper format, then you'll get a 5. Data, so all the charts are included. They're all labeled and titled. And then data validity, it's just making sure that anything that you are like figuring out, so if you're doing, you know, division or addition, or you're labeling a part in a microscope picture, that's all there. And if it's inaccurate, so let's say for this lab, you got density of like 25 grams per cubic centimeter, you would explain in the conclusion why that number was so off, right? Because we've already talked about this in class. If your numbers are accurate, that's just, it is what it is. But why did you get those wildly unexpected data points? Right, the conclusion or summary must verbalize all the data and charts and describe how the lab correlates to the information addressed in class. So if you don't verbally summarize the data, you don't get any points. So make sure that you do that. And to get full credit, you have to demonstrate that you understand how this ties into what we're learning or what your data means. And then the lab specific questions need to be in a full sentence and accurate. All right, so that's what we just went over. Then we have our format. So I showed you the template. So you can see it's already formatted for you. That's in the heading. So don't start typing right after the heading. Go to the next line and you'll see I put it Times New Roman 12 point. Right. So to get full credit for the format, you submit that template back through Classroom. You don't add it as a doc. You don't change the size or font or write in weird color or anything. Then you're writing full sentence and grade level writing ability, conventions, self-explanatory, grammar, spelling, and punctuation. And submission, this is what I was talking about in terms of submitting it with your lab partner. If it's handed in on time, in the correct format, as I spoke about, right, not as an added doc, not emailed to me, and only one person should be submitting it if you're submitting it as a lab group. Okay. So that's how your grade is derived. And let's go to the cheat sheet for the Penny Lab. So this is what drives what you're writing in the lab template for each particular lab. You'll get one of these for each lab because it's specific for that lab. So title, we already know, density of Penny's lab. And state what the purpose of this lab is. So there's different takes. There's no real right or wrong answer. If you want to go down the route, this lab was to use different densities of pennies to practice our triple beam balance skills and volume measuring skills. That's one option. Or if you want to we were looking to determine if there was a difference in the density between pre-1982 and post-1982 pennies. Again, there was no real right answer. Why do you think we were doing this lab? All right, then the background. So this is all the information regarding the lab. So what do I need to include? What is density? How can the density of an object be found? I don't want you to do the procedures. That's not necessary. You're just talking about background information so someone could look at the results and understand them. How can the volume of an irregularly shaped object be found experimentally? What is the composition of a penny? Now, where do you get this information? Most of this information is in the full lab procedure that you get with your pre-lab, right? We get an easy to read version when we're doing lab, but the full lab will give you in the preamble most of this information. If not, I usually put links. So what is the composition of a penny? That was in the preamble, but I also put a link of what that is. So if you didn't know, post 1982 pennies are 2.5% copper and 97.5% zinc. And you saw that when I went around with the cut pennies. And then how has this composition changed over time? Again, if you, most of it's in the preamble, but this is the specific information. So you can go to that link as well. And when did it change? That's included in that link. And what is experimental error? I'm going to explain that. You can Google some of this if you don't want to read the preamble or if you don't feel like that's included in the preamble. All right, so the data, these are the tables that you're going to provide. If it's not acceptable to take a photo and insert that into the lab, a photo of your lab notebook, and everything has to be labeled and titled. So, for example, each one of these should be titled Table 1, Trial 1, Average Density of a Penny based on mint date. And you're going to complete these in Google Sheets and then import them in. You can add them as a table, but it's really difficult to format and enter the data with that when you add them to a Google Doc. All right, the conclusion. Again, you must verbally state your data and explain it. And you want to relate any materials viewed, observed. So you can even talk about what did the cut pennies look like in this section. This will be about a paragraph. And you're going to kind of tie this in. So one of the things too, if you got very strange data, you would explain where that experimental error came from possibly, right? So let's say you got density of 10 grams per cubic centimeters, and that's larger than the known density of pure copper or pure zinc. So you know that something went wrong. So you would explain error may have been introduced by water being present on the pennies that were weighed. So make sure that you include any weird or bad data in the conclusion. And then finally, you're going to answer the questions by restating the question in the sentence and then answering it correctly. All right, so let's just look at an exemplar of an old lab. So in this, they submitted it with 2 other people for the same grade. Now, if they had submitted it by themselves, there would not be any names here, even though you did the lab physically with them. If I see this, I'm going to assign the grade for this lab report to both of those people. So make sure that you do not put someone's name there that you're not sharing the grade with, right? So here's an example where the format's wrong, right? So it's under the heading, so they probably went to the heading and then hit enter. And then the purpose, find the density, and through that, identify the composition of pennies based on their mint date. So that's not a full sentence. So you want to make sure that you're writing in full sentences. All right, so remember from that cheat sheet, we have the questions that we want to include. What is density? How can the density of an object be found? How can the volume of an irregularly shaped object be found experimentally? What is the composition of a penny? Has composition changed over time? So I'm just going to go through this quickly and not completely thoroughly. We were told to find the density of pennies separated into different mint dates. Density is how much mass is in a certain amount of volume of an item. Okay, so that explains density slightly. Right, density is how tightly packed the atoms of a particular material are, so you can add that. And then how can the density of an object be found? We use a graduated cylinder to measure the penny's volume with water displacement because you can't just do length times width times height for the volume of an irregularly shaped object. Now that's true, but this isn't really asking about the lab, although that's not wrong. You could just put that they also forgot to put that you have to mass the object, right? So they're talking about the volume by fluid displacement, but they're not talking about how do you get the mass. And density is mass divided by volume. So this wouldn't be 100% accurate. And then they talk about the penny's composition, but they don't actually say what the penny composition. They say both copper and zinc were used for the composition, but that's not really true, right? Pre-1982 was copper. And they talk about what experimental error is, something that is being measured inaccurately or observed inaccurately. But you don't have to, in this background, talk about what happened in your lab. I'm just asking, what is experimental error? And why is a larger sample size more accurate than a smaller sample size? And we know that a larger sample size, when you have a lot of objects, small differences between individuals become less important because you have individuals on either end. So if you only have one or two things, if they have small differences, those are more likely to interfere with the results. And here's your data. So they did a good job. They inserted a table, but they didn't title them, right? So trial one in the data table is not the title. So, and you can't use data tables of trials to find density of pennies because there's more than one table. So they each have to be titled individually. And then you have your conclusion. One of the things with the conclusion is that you don't want to have bias. It shouldn't be, I like this lab was hard, um, this was a good way to do something. You can see right here. You're just going to summarize your result. Trial one seems the most accurate and realistic given the actual densities of the pennies wavered, spelled wrong, from around to 7 to 8 grams, depending on the year. So you don't want to do that. You don't want to talk about it wavering. You want to be specific, right? The pre 1982 pennies in trial one had an average density of 10.3 grams per cubic centimeter, 1982, 4.8 grams per cubic centimeter, and 5.1 grams per cubic centimeter for post 1982. And then you can compare it. And you can even do an average for all three trials, which is really what you should be doing, and then talking about that in the conclusion, and compare that to the density of zinc or copper. Okay, and then they forgot their questions. So that would be a little bit of an issue in terms of losing points. And the submission has to be through Google Classroom. So you're going to be working on your lab report with your lab partner or individually, but decide before the lab is due whether you're going to submit them together or individually, so both people have time to actually finish the lab report.